Hello, everyone. We're just going to wait a little longer to give some time to more people to join the webinar. So if you bear with me for a moment. Okay, I think we can start. So welcome everybody, and thank you very much for joining us today. The event today is back to basics modeling cash flows from a bond portfolio using R. Before we get into that, I just to mention that the webinar is obviously being recorded, as it is the habit has been for a while. We hope to post it in active view shortly after the event is finished. So keep an eye for that if you're interested in rewatching it. The Q&A section will also be recorded, so you can enjoy that too. And you can submit your questions at any time during the meeting using the facility that you have in Zoom. What I'll do is I'll read the questions aloud. And I think we discussed this with Mick, the presenter today. He's happy to take questions throughout the talk. So I'll just pick a good moment to interrupt him and throw the question there when I can really throw him off his of his talk. So by all means, don't be shy and send your questions as they pop up. And another thing I think I should remind you is that once you've registered with your full name to this event, the Society of Actuaries will have recorded your attendance. So you no longer need to put verifiable CPD in the Society CPD scheme, but you might have to do so for other organizations. So just bear that in mind if you need it. The background for today's talk was we were discussing in the Data Analytics Committee about what kind of events we should be organizing, what the membership was interested in, and there seemed to be a common theme about going back to basic skills, at least in using R or Python, and trying to go back to something that was also common to many actuaries, not only those interested in data analytics or machine learning. And that was really the genesis for the talk today. So we persuaded Mick Cooney, who was always been very generous with his time, so it didn't take a lot to persuade him to do it. And so the talk today is really going to be about that, about how you model a portfolio of bonds and their cash flows, how maybe you can automate that in an efficient and maybe best in practice type of way. So that'll be it. Mick Cooney has a background in quantitative finance. He's been working in insurance for over 7 years, and he's one of the co-organizers of the Dublin Data Science Meetup. He's also been statistically proven to make bad tea, which I can confirm, and I know this because he once complimented me on my tea, which is not really bad, and that's how I knew his tea had to be bad if he found mine good. In addition, Mick is very, very modest, and he doesn't mention these things, but he's also been involved in a lot of innovation projects supporting insurance. He was part of the Lloyd's Innovation Lab years ago. He's supporting Lloyd's entities as well with innovation projects. And in a previous life, he was involved in designing investment strategy for options trading for hedge funds, which I always thought was a fascinating topic, and he's never talked enough about it. So maybe for a pint one day, he can tell me more about it. And with that, I'll leave you with him. So just remember, you can post questions anytime, and I'll stop Mick to go through them unless we were breaking too much his flow. Okay. And so the usual disclaimers, and just for you to see how this talk fits in the competence framework for the Society of Actuaries. And with no further ado, I'm going to stop talking and I'll leave it to Mick. So thank you very much.
Thanks, Pedro. Let me just share my screen here. So yeah, so let me just zoom in a bit here, make it a little bit bigger for the screen. So yeah, I'm hoping to do something a little bit different today. So first of all, thanks very much for having me talk. It's an interesting full circle because I'm a personal friend of Pedro's, but we actually met at a Society of Actuaries event, I think in 2014, when you were doing the machine learning thing that you were organizing. So yeah, Pedro had asked me for a while to give a talk, so I'm always happy that there's, I definitely conform to the old adage that I'd show up at the opening of an envelope. So I'm more than happy to give talks on anything. And like Pedro mentioned, the idea was that there's been interest expressed in, we want to use R, we want to use Python, but we don't necessarily know where to start. And one of the problems and one of the kind of the personal bugbears I have with a lot of machine learning and kind of data analytics and data science and all the kind of fancy buzzwords that are out there is that they tend to focus on somewhat unrealistic and very impractical kind of fancy, sophisticated, academic problems, or like real world kind of fancy things done by kind of, very modern companies where, they've got all their data in line and, they're actually, the companies have came around with a very data first approach, and in a lot of highly regulated industries like insurance that have been around for 300 years, that isn't always the case. And just the very kind of bespoke nature of a lot of deals, and the way that just things get very, very messy, and you can't really do those fancy things because the underlying foundations just aren't there in terms of the data systems, and you've just got highly onerous work schedules that just don't really lend themselves to any of that. So kind of where we kind of fell down and where we kind of settled on was just doing something very simple where in some senses the underlying topic isn't that important. It's just a very kind of boring, everyday run of the mill kind of almost admin or maybe regulatory function in terms of reporting. So I kind of went back into a job I had to do back when I was a quant, on a very, it was almost like an aside. I was doing some other stuff and the trader guy had this issue and he said he knew I'm kind of technical and could I essentially solve it for him. And the problem he had was he was running a leveraged high yield debt portfolio, and what he was Canadian, and so they were kind of a cross between both Canadian and US issuers that he had built the portfolio from, and he needed to hedge his risk. He wanted to think about, like, he could just have got forward in terms of hedging out. I think his base currency was Canadian dollars, and he was hedging the US risk, or just maybe the nature of the fund. I can't quite remember. It was one way or the other anyway. But he thought rather than creating a forward every single day, there was a cash flow event. What he wanted to do was get a sense of where, like, what was the aggregated currency risk of all the inflows, and then he could hedge it using futures. So what he basically needed me to do was, given that he had a portfolio, can I kind of project forward the cash flows, like, because there's a 6-month coupon, and there's a maturity date as part of it. So just project forward all the cash flows deriving from the bond portfolio, and basically that would enable some other work. So that was kind of what I did, and that just seemed like the good basis of just giving the talk, because it's, like I said, it's not particularly sophisticated. You can kind of get in the data we had, and what made it a little bit more challenging was, and this may not be relevant for a lot of you, but we were kind of working on it was a very small organization, so we didn't have any impressive IT or anything. It was basically whatever we had kind of got together, and the systems we were provided, certainly in North America, the capital markets kind of back-end admin stuff is very, very simple, and very, very rudimentary. And it didn't have a lot of the stuff you would probably expect as part of the reporting. It was very, very bare bones, and kind of you had to tag on everything else, which is kind of part of what I'm going to talk about. So we kind of had to almost, like, it wasn't like you got a bunch of nice columns where you had, what the underlying company was and what the coupon rate was and what the maturity date was and any of that stuff. It was literally just a single symbol which had all that data kind of embedded in the string, and you had to parse it out and create the maturity date. Sorry, I keep calling it expiry because of my options background. So you'll kind of hear me mean the same, even though they're not. I should be, when I say, if you ever hear me say expiry, I mean maturity. So yeah, so then bond, and it would repay the principal upon maturity. So that's another cash flow event. And just build out basically for each portfolio, for each bond in the portfolio, expand out all the coupon payments and the final maturity payment. And that essentially becomes a big table of all the cash flows by date. And we went with very, very simple assumptions of essentially it's paid every 6 months and until maturity, and 6 months from issuance, which we had as well. And it pays it every 6 months. And usually the bonds are, in units of 6 months in terms of issuance date to expiration date, or maturity date, but that didn't always happen either. So there was a little bit of jiggery pokery around that. So just, relatively simple things, but they're the kinds of problems that I certainly have to deal with. And I don't work as an actuary, like I'm not one. I have worked with them though, so I kind of have been quite familiar with some of the problems you have. Now I know it really depends on whether you're life or pensions or, general or health or whatever. They're all, but some of the underlying problems were quite similar. So this is kind of what we've kind of done. So it's not particularly fancy in terms of, here's something cool you should do. What I really want to focus on for the day is kind of how I did it. And also if any of you were interested in there, maybe it's going to provide at least, a couple of road markers on the way to, if you think, you've got this very labor intensive job that you're currently doing in Excel or with SQL or something, and you think, actually, from what I know, with a bit of coding, I could probably just create a script that will do this for me. At least now I'm hoping, or if you have any questions about it, I'm certainly happy to talk about it further. Just give me a shout. That's kind of what I'm hoping we'll get from that. So it's not, like I said, it's not so much what I did here. It's kind of how I did it is going to be the main focus. So the way I'm also going to talk probably about, like, not necessarily the presentation, but the workbooks and things like that I tend to use sometimes for this kind of work. Now, it's not always necessarily very suitable if it's an automating process where kind of what they call ETL, extract, transform, and load. But I'm happy to talk about even like the choice of packages and why I chose them and why I lay things out the way I do and all that kind of stuff. So it's much more about the method than it is about anything else. And like Pedro said, I don't necessarily see the need to wait until the end for questions. So I am more than happy to be interrupted during the talk. Pedro can just jump on and ask whatever needs to, and by all means interrupt me. So, if you have any questions, just pop them into the Q&A. We will probably try to address them as quickly as we can. Now, there may be some that are a little bit tangentially related or need further discussion. So we might leave that till the end rather than interrupting the flow too much. But by all means, if you have any questions for me whatsoever, by all means, shout out. I'll happily address them. Now, the other thing I want to address is I did all of this in R because R is kind of the language I'm most familiar with. You could do pretty much all of this probably almost exactly. Like, there's not always a direct Python to R kind of translation. Some libraries are in R that aren't Python and vice versa, or they're not like direct equivalents. But the other benefit of kind of solving this particular problem was it was relatively simple. So you could almost certainly, I'm not an expert on pandas, but my knowledge of pandas is such that I'm almost certain you could take this code and very easily translate it to Python if Python is the language of your choice. So that's kind of where I'm coming from. So so that's basically where I'm going to start. So I had, so what I've done all this, obviously, the work I was doing back then was essentially proprietary to that company. So I can't use like their portfolio stuff, even though it's very out of date. So what I did was all this code is available on GitHub, which for all the talks I've ever given. So if any of this is interesting at all and you're interested in other things I might have spoken about, because I do talk about insurance sometimes, or if I'm giving very generic talks, just the nature of my experience, I often talk about what I experience in insurance. By all means, check out my GitHub account. Most of my talks are in that data workshops repo, but I do have a few others that may be of interest. So all of this will be available afterwards, and the link is provided there. We'll probably share that link in the chat as well, or maybe afterwards. I might do that a little bit. In fact, you know what? I will do that right now, just so I don't forget, so that you're not scraping off the screen. I'll just pop that into the. I'll just, Pedro, I'm putting that in the whatever the host and panelists. So maybe you could share that. So yeah, so that's basically where I'm coming from, and that's what I want to do. So what I did, and like I said, I generated a kind of a fake portfolio, updating everything. I made, you know, the dates more modern. I literally just kind of, it was completely synthetic. It's random generation of pricing, and whatever issues were on there. Like, it bears no resemblance to reality. So if any out there are working in ALM or anything like that, please don't try and take anything I'm saying in terms of the actual portfolio as useful, because it's just completely randomly generated, and you will kind of see that as we go on. Like, there's an awful lot of, you know, like the durations and stuff that we calculate are kind of built in there. Okay, so let me just expand the code. So I'm using a workbook here for all this code, and I'm just going to show all the code, which I don't normally do. But like I said, now the other thing I'm not going to do is go over my code in too much detail unless someone has a specific question, because I try to make code as readable as possible, although that's not always possible. But instead, what I want to do is, I've kind of got everything that's in the code. I'm not really loading too many libraries in from other places. So most of the code in this is kind of in this workbook. And what I'll try and do maybe is just talk about my thought processes and why I did things the way I did, like why I wrote a function for this, and just talking about kind of how I'm doing things. And then, so I'll probably give some very kind of hand wavy discussions of the functions I'm reading and I wrote, but I'm not going to go through each line and say what it is. Hopefully most of them will be fairly self-explanatory. And like I said, I'll give kind of a high level description as I'm going through it. So, okay, so the very first thing we needed to do was load in a portfolio. And, you know, there's some very nice packages as part of the tidyverse now. Any of you are familiar with R will probably have heard of the tidyverse. So there's a package in, I just library tidyverse now because I bring them all in, but you can go separately. And there's one called readr, which is all about reading and loading data from whatever data file into memory. And it's got some nice kind of syntax around typing of the various columns, because, you know, like if you're doing an export from Excel or a CSV or whatever, sometimes dates are written in string format, so they look like a number, or you have ID columns, which are read as a numeric, but they're actually really a string, because you shouldn't really be doing any arithmetic on them, that kind of stuff. So there's a nice kind of way of setting all that, and you can kind of tell what's a form, you know, what's a date and what isn't a date. So I just generated this sample bond portfolio has been generated by my other code. And there's, like I said, I won't go through that code for this talk, but it's all there if anyone's interested. It's not particularly clever. It just randomly generates some numbers. The one thing that NA is like a missing value, because in a lot of data, sometimes fields are missing. So they're like null, and null in SQL, for those of you who are familiar with SQL. I kind of had to explicitly change that though, because, and this is one of those gotchas that I always forget about. Sometimes NA is a string. So for example, North America, or if it's a symbol, because I'm dealing with US public companies and Canadian public companies. So I can't remember which one, but there are a couple of companies that had NA as their ticker symbol. When you load them into R, they'll read them as a missing value, and it slightly changes your results. So that's just saying that a missing value is N/A, kind of like what you get in Excel. I think there's a hash in front of it. So I'm kind of rooting that in. And then I'm also just doing some basic parsing on the ticker symbol, because you can see that was, and this was kind of, if you look at the string there, this was kind of what we were getting off the admin report of the positions, the overnight positions in the portfolio. It was a ticker symbol, a yield, a nominal yield on the bond, and then the maturity date. So that was kind of how we were inferring it. And yeah, and there's just like a position, a price in terms of 100, what the coupon rate was, issue date and maturity date. So I kind of have all that in there, and I'm just pulling out the ticker symbol and the coupon from it. Oh no, actually the coupon was part of it. Now in the real world, you might have more data. You might, I mean, like I said, depending on your IT systems, but certainly if you're interfacing with old systems, which in my experience, still a lot of these, financial institutions still have very kind of old school, AS400s and stuff. Sometimes it is kind of that rudimentary, and you have to do a bit of, data manipulation and munging to kind of, you've embedded data within a single field and you have to kind of pull it out. So I'm just kind of doing a bit there, and that can be often quite tricky. So one of the reasons why I tend to do that up front and I do it here rather than manually is because it becomes, what I tend to prefer to do is to take the data in as raw a form as is possible, and then do all my data manipulation and munging kind of in the code, rather than, even if it's a really simple thing, like there's two values and it's spelled in two different ways, like, color COLOR and color COLUR, just off the top of my head. Obviously, you want to change them into the one. Rather than doing all like a global search and replace in a text file as an input, I would generally parse that in the code here for a couple of reasons. One, when you get a new source of data, which I often find myself having to do, like I've ran it before, I'm going to be running it again, I'm going to have to remember all those manual steps. But secondly, it also becomes much more auditable, so that when you're trying to like recreate what you've done, it's all written there in the code. Now, that might be as simple as, sometimes, obviously, it's a messy thing where you have a whole bunch of data that just needs like a manual override. Sometimes what I'll do is I'll just create it like a separate CSV file that says, for this particular row in the column, like in the data input, this value turns into this value, or for this particular ID number that I've loaded in, we know it's been miscoded or something weird has happened to it. So therefore, I'm going to change it from this to this. And I would rather have, from my personal experience, just from a data kind of cleaning and validation point of view, I'd rather have all those transformations in a single place where I can kind of look at them and check them. Now, I know obviously if you're bringing in a CSV with the overrides, it's not, technically you've got two, so because you've got that other thing, but I can save that with the rest of the code, or I could just put it into a spreadsheet, but that gets, or into I could actually just manually code it in. But that gets a bit messy. It's usually easier to just kind of have the data that I can read in separately as a CSV or whatever it is I need to do, bring it in, and then kind of do those kind of messy, dirty kind of manipulations that real life data often requires. So yeah, so that was loading it in. Now, like I said before, we had a bunch of issues with the reports because it was just coming off like the back end systems in North America, which have just never been updated. I think it's just one of those systems where, because so much hangs on it and it kind of works, no one really wants to touch it, because anyone who tries to touch it is career suicide. So there's a whole load, and if there's any out there kind of nodding your head and understanding where I'm coming from, it's not a particularly unique phenomenon. So basically, in a lot of cases, what we were getting, now I think in a lot of other places you would have kind of infrastructure built around all of this. So even though the data is coming in, it's then going through some kind of, clever ETL process, but we didn't have any of that. So I kind of had to do all this myself. So we kind of had to bring in like market cap data, which, I basically got it saved in the data there. I've kind of got it from another source, but that way we can like segment our portfolio by the size of the company. But we would need the market cap for that. So I've kind of loaded that in separately. I'm also loading in some very simple company information. All of this is US Canadian public companies. And I think even particular, it's even Canadian companies that were linked in the US. So, there's a fair bit of publicly available data from them, and that might be useful from a risk analysis point of view, or just audit reporting, or whatever it might be. So we kind of bring all that in as well. So you've got an exchange, you've got the GICS code that got provided as a code number. So there is a package out there called GICS that isn't actually on CRAN, which is the main library for all the R code, but there is a GitHub package for it. That gets, I installed that as part of the build process, which I'll probably talk about. It's not directly relevant now. I can talk about that at the end. But that brings in things like, it links basically the code to the various sector names and the industry group and industry name and what. And that way we can start slicing and dicing the portfolio down these kind of categoricals if we want to.
Mick, sorry, if you might stop you there for a moment.
Of course.
You're using read CSV, and I know there are many other options.
Yes.
I don't think it makes much of a difference in this example, but
Yeah.
Would you want to talk about the different options and why you would go
Yeah,
for read CSV in this case?
sure. So thank you. And I know we actually talked about that, so thank you for reminding me. So there is a few ways of reading data into R. I mean, there is a base R. So so R is slightly different to Python in this way, in that kind of the whole data analysis stuff on Python is a relatively new addition to the language of Python. You know, Python and R have been around. Actually, R I think has been around. Well, R hasn't been around longer, but it's based on S. So there's actually a few different ways of loading the data, like a CSV file, into R. And there's actually, you can load it directly from Excel as well. There's a read Excel package, which allows you to read Excel files directly and does not a bad job. Sometimes it can be a bit tricky, and it doesn't have this nice format for read Excel. So sometimes I end up reading everything as characters, writing out with CSV, and then reading it back in again, which I know can be a bit messy. But sometimes I've done that because just with Excel, it can be, especially with dates. And if you've got strings that contain digits and look like a number, it'll drop leading zeros and stuff like that can mess up your joins later. There's all these kind of niggly bits that can get quite annoying. So that's something I can do. So there's read.csv, which is base R, which the tidyverse is a relatively new thing. It's been around since about the mid 2010s. That kind of has read.r has like read_csv, read_tsv, tab separated values, read_delim. There's a bunch of different ones there. JSON, if you've got data in JSON files, it can read. There's a JSON Lite, which is part of the tidyverse. So they've all that. There's also read.csv, which is the base kind of part of the base package. I have found I prefer read_csv because it just has a lot of these. It's not quite as fast as read.csv is, but in most cases it doesn't really matter. And these kind of things here, you don't get access to these kind of nice kind of quality of life data typing for the columns stuff that the tidyverse gives you. Now, there is also a package called data.table, and not to be confused with the data table you will see me use here, because that's a JavaScript thing, because it's nothing if not confusing. There is a package called data table, which is basically built for high performance. So if you've got a large amount of data, like, and assuming you've got the RAM on your machines, but if you've got, say, like, 50 million rows or 100 million rows, and you've got to process that data table might be useful for you. And it's got a package called fread for that. I think it means file read. And that does read things. That's definitely faster than read_csv, but it doesn't have the nice kind of syntax and ease of use. So when I write code, I don't worry too much about performance in general unless I have to. And even then I worry about it later, because the most important thing for me is kind of brain power and attention. So I try to make things as simple as possible. And might write my code as readable as possible, simply because one of the R guys has something which is true of coding in general, is that typically whenever you're doing this kind of work, you're coding for at least two people, you and future you. And what you don't want is future you to hate current you, which is very easy to do, because it's very easy to just smack down a bunch of kind of spaghetti code that just about gets the job done, and you don't really worry about it. The problem is when you will if you've done it before, there's a good chance you'll end up doing it again. And it might not be immediately. It might be like in a year's time when the next reporting thing comes around and people go, oh, remember that cool thing that you did that did the stuff? Could you do that thing again? And then, of course, it's a year later, you've completely forgot all the little bits that you had to do to get it to work. And also your code looks like it's been written by a deranged psychopath, which is certainly what happens to me. So I kind of had to I'm still not great at it. I won't admit I'm not definitely great. I can be a bit sloppy at times, but I almost always regret it if I don't spend at least a little bit of time and attention just to like line up my columns nicely, try and make it as readable as I possibly can, and try and do that. So you've kind of, to go back to your original question, and this is the danger of asking me questions, is I tend to go off on three tangents. If you have like, you have the three options. The one I almost always would recommend people to use is read.r and this read_csv, purely because it's better generally than read.csv, because the performance difference is usually negligible for the kinds of problems you're going to have. And If you've got to go into data table, it's a different thing, but you kind of already know that you've got those kind of problems, and that's kind of a conscious choice you can kind of make. So I hope that kind of answered the question, Pedro, or is there any more?
No, it does. Thank you.
Okay, cool. All right, so yeah, like I said, we're kind of, like I said, we've got a very bare bones input. We've got some extra data that we need to append onto it because, you know, we don't have all the bits that we actually need. So all this really is just leading that. And the other thing I always tend to do is when I load data up, I immediately, this glimpse thing just gives you a very high level view of how many rows, how many columns, what columns there are, and what the data type is. And that can be really helpful just to check that what you're doing is what you're doing. You'd be amazed at how often you load data and the data you've loaded isn't the data you've expected to load. Like there's been some kind of weird parsing error and the file doesn't get, especially, you know, when it's dealing with files that you don't really understand the provenance of or you haven't necessarily helped create. You can have these weird things where like null characters get introduced into the file. So therefore it thinks it's an end of the file. It doesn't look any further and it stops parsing the data. So you end up with like 50,000 rows when you were expecting 500,000 rows. Or the other one I did in a workshop for Dublin Data Science last year was I was reading an Excel file and it was in 2 tabs and I forgot to check how many tabs are in the file. So I loaded half the data and it wasn't until like, you know, a while later, I kind of wasn't paying to my attention. It had said on the website that there should about 1 million transactions. And when I looked at the data, there was only like 500,000. And I was like, oh, that's a bit odd. And it was only then that I realized, oh, wait, there's 2 tabs in the Excel file. I actually need to read the data from both tabs. So it's very handy just to do a very quick sanity check of the data to make sure that it's amazing how often that will actually save you like a week. I back in when I was doing a lot of naive stuff back in the day and wasn't doing this thing because why would you bother check this stuff? Surely it's self-evident. Just simple things like checking that the number of rows is roughly what you expect and the number of columns is roughly what you expect. And then, you know, do these things all look correct? And it will help you just find out, oh, maybe there's like other silly things like maybe I need to skip the first number of rows in the file because there's like header information in the spreadsheet that I don't care about. And the data actually starts like 6 rows down. So I need to check the 5. And if you haven't done that properly, this won't, you might get the right number of rows and columns, but the column names will all look wrong, or it'll give you you'll get parsing errors where you shouldn't have them. You'll get all these kind of weird errors. So it's very good to just do even the really basic things. So I tend to be very liberal with things like glimpse and stuff like that, that just prints out the data I want to look at and just to helps me check it. So that's kind of what I'm doing there. I've got the GICS data. For this particular data, I won't go into too much detail on it, but what I was there's a typo there too. I wanted to be able to segment my portfolio by market cap size. But the problem is, how do you know what counts as a large cap and what counts as a small cap? That, you know, it depends on the data and we don't necessarily have the full universe of stocks. So there's a whole bunch of quantitative research being done by a guy called, it was Eugene Pham and Percy French. I think Percy's his first name. They are basically, they worked on things like the capital asset modeling and all that kind of stuff. But they do they provide a bunch of data on their website that gives you the various breakpoints for the different percentiles for public companies. So I just find them a very handy benchmark to use. You know, everything in the upper quintile is large cap, you know, or macro cap or whatever I can't remember, mega cap, sorry. And then you large cap and small cap. And they kind of have they thought through this process quite well in terms of, because you've got this long tail of very small companies. So yeah, so just if any of you do work in like anything to do with ALM or capital markets or anything, I do recommend having a look at their website. They do have some handy CSVs that they like update every month that do some nice breakpoints. That were inputs to the research they do on capital asset pricing, but it can be very useful for like other related fields where you need to break this up. So it's a similar idea. It's just kind of messy. When you look at the file, you'll see I'm just kind of trying to get around this slightly weird structure. So I've got some, you know, character counts in there. There's some weird files where it's a bit kind of ragged, so you've got to kind of deal with that. And I'm just kind of bringing all them in, and these give them in 5% breakpoints. So I've brought them in because what I'm going to do is take those breakpoints and reduce it to 5. So I'll take like the 0, the 20, the 40, and so on, and kind of reduce it that way. So yeah, so there's a whole load of data in there. Also, as I said, I brought them in and I just kind of created it. But for the data we had, because the trader in particular wanted to look at where he was thinking in terms of hedging his currency risk, and he didn't necessarily want to go with forwards because he figured he'd always pay a spread. He figured it was easier he'd get a better price off the currency futures, and as long as the aggregated FX risk didn't get too big, he was, or basically could tell him when he needed to start thinking about trading or paying attention to stuff, and he would kind of have a calendar schedule in advance of the relevant points. And we kind of implemented that just to kind of show you kind of how that worked. But I also, as a result, I need to know when those expiration dates are or the delivery dates for those forwards are. So I brought them in and I can use them a little bit later in my aggregation. So I'm just processing the bond data. I kind of, this is just me breaking things down into the different bands for the breakpoints. So like I said, we have 20 breakpoints. We're breaking it down into what is essentially 5 of them, and just using cut and kind of so that I can basically go to the market cap data I have for each company in each bond. I know what its market cap is, at the end of 2018, which was essentially when we were doing this, at least nominally in this workbook. I can compare it to the various breakpoints and then essentially assign it a quintile for the company size. So that's kind of what I'm doing there. So I end up with, and it's CIK number, it's off Edgar. So I'm kind of using a few different lookups, and I'm kind of joining them all together and creating a big lookup table of all the companies that we care about that we can join the other data onto after, using essentially what like left join, which is, for those of you who've used SQL, it's exactly what it says on the tin. It just kind of have a table here, have a table here. They both have this ID column, and I'm joining where those values match. I also tend to use left joins because rather than, so there's two ways you can join the data. You can join them where you only keep the rows that match, whereas a left join, you keep table 1, and I'm sorry, I'm going left and right. I should probably do it this way from the way you guys are looking. But the first table 1, all the rows of table 1 are preserved, and if there's no matching row in table 2, then it just kind of leaves those columns blank. And the reason why I tend to do left join rather than inner join is, even if I'm expecting everything to match and there's nothing like that particularly shouldn't match up, again, I tend to use left joins and then check for missing values, because that tells me that either something's gone wrong with my data, or I've just made some very high level intuitive assumptions about what's going on that is not actually correct. So part of the thing I tend to do defensively when doing these kind of things is I'm constantly doing in relatively simple sanity checks just to make sure that I don't have a bug in my code, or I haven't got a logical flaw in what I'm doing, because it can be very easy with these things. They can get messy, and certainly even something as what you would expect to be relatively straightforward, like US public company data, because they've got to do quarterly earnings and all that kind of stuff in a relatively predetermined fashion every 3 months. It's surprising how messy that data can get, especially because of splits and mergers and all those kind of things. So even getting like a census of what companies are around and stuff can be quite messy. So it's very handy, I find, just from the point of view of, for a couple of extra lines of code here, or just some simple extra bits and pieces that I'm putting in, I can just check that at every point I'm not saying I'm going to catch everything, because I generally don't, because you'll always have weird stuff, especially when you're dealing with real world data that's coming off some kind of database dump or report or whatever it is. There's always going to be issues with it, and you just try and catch as many of them kind of as cheaply as you can, so that the flip side, of course, means that when you do have problems, those ones do tend to be doozies that can be quite difficult to solve. But at least you're kind of capturing as much of the easier stuff, and you're kind of raising the bar for what mistakes that you're making. So again, so I'm putting all them left joins in, and I'm just kind of creating the table. So I end up with kind of a lookup table for each of my companies. You can see there's about just under 6,000 of them between Canada and the US, and they all have basically, I have the ticker symbol and country code and the currency, which is just appending a D in this case, because it's just US and Canada. So it's USD and CAD. And then, we have the sector names from the GICS. We have a market cap. And the one that we're going to be mainly using is just the quintile, though. We're not necessarily going to use, now that we actually know what quintile it's in, that's the only thing we really care about when it comes to market cap. But, if depending on your risk analysis, maybe you need to do something different. So, okay. Any questions, Pedro? I realize I'm talking a lot, so.
No, not so far, thank you.
Okay, cool. All right, so now that we're done, basically, I'm going to take my portfolio data and I'm just going to append the company lookup. So I kind of have the portfolio data in advance. And like I said, in most cases, when I initially got this job, I assumed a bunch of this data would have been provided in the report, so that we would have had even simple things like the extra columns that told you like the coupon and all that. Now, in the data I had, and I can kind of show you a redacted version of it at the end if we have a little bit of time, we didn't have any of that. I think we had the issuer, the date it was issued, we had a symbol. We had to infer an awful lot of the things off it, including like the coupon and the maturity date. And we had a few other bits and pieces, but we really didn't have a lot of stuff. So kind of this was me kind of solving that problem and just appending everything on. And I tend to do it that way as well, just again, to focus on the why rather than the what. I don't really have a good reason for why I do this way. And I guess it's just kind of the way my style has evolved, doing a lot of these problems over and over again. What I tend to do is if I'm creating something like this, where I essentially have some input data, and then I have a whole load of like data enrichment or data enhancement that I want to kind of append onto a table, rather than do it piecemeal, what I tend to do is construct this entire kind of enhancement table separately, and then just join it at the end. So that I kind of tend to construct, and you can see that kind of in the code if you look at it later. I'm kind of assembling that table separately, and I'm not really looking at the portfolio data at all yet. And I'm building that big kind of reference table as a single lookup table that I then append on to the portfolio data later, or to the cash flow data. And I actually, just as I say it now, I don't have a particularly good reason for why I do it that way, because there's nothing to say that you couldn't do it the other way, where you just kind of build your table incrementally. I'm not quite sure why I do it that way. I'm sure I have just off the top of my head, it could be just, it was easier to name variables that way, because I like having the different components and not overwriting existing variable names, for the simple reason that if I find I've got a flow from top to bottom, and I'm doing some, basically a flow of control where I'm starting with some data, I'm doing stuff, I'm doing more stuff, and I'm doing more stuff, and I'm doing more stuff, I try not to overwrite existing variable names, because if I need to debug it, I now have a copy in memory of all the different intermediate steps. Now, of course, if you've got memory issues, that could cause a problem. So maybe you just overwrite it. But I do find, rather than having to arbitrarily start commenting out code, if I'm fixing stuff, it's nicer to have in memory separate variables that, at each point, I kind of have a separate value. So I can look at what was in that table at this point when I'm debugging it, trying to figure out, the unexpected behavior, what has gone wrong. So I'd say the reason why I kind of do that, create a big construction table and then append it on, is it just makes it easy. You don't end up with bond portfolio 1, bond portfolio 2, that isn't particularly meaningful in a naming point of view, and isn't overly long, where you get 40 character variable names that are just kind of hard to fit on the screen. I don't want to have single or two. I try to make my variable names as kind of descriptive as I possibly can, but I don't necessarily, you don't want them to be too long either. So I'd say it's probably something to do with that. Now that I've kind of asked that question to myself in my head, why do I do it this way? So yeah, I tend to build a big kind of lookup table that has all the stuff that I'm going to be appending to my input table, and do it that way, and then append it all on in one step at the end, just so that I'm not overwriting the other stuff. So that's kind of, I'm asking and answering my own question there. So I've done it with that way. And, now we have essentially our main input portfolio table that we can, do some very simple things on. So just, I'm just outputting it here. I'm not really doing anything. I'm just counting. I had to segment everything by currency, obviously, because some stuff is in Canadian dollars, some stuff is in US dollars. So You don't necessarily want to aggregate them. I could have brought in the FX rate, and I think at some point in the real life work that I did do that, and I think I had projected currency exchange rates at future points in time as well. I think I had the various forward rates, I think. I'm trying to remember all that, but I didn't want to. That just gets very messy. And while obviously it's real world, and I don't necessarily, I didn't want to completely shake away all the messiness. Also, from a data generation and point of view, I didn't want to, go too over egging it. So I just kind of ignored all that. But there would be no reason if you had to do that and you had to bring in an FX rate, as long as you have dates for everything and you can match the dates up, you could totally do it that way. And that way you could aggregate the entire portfolio down into both, a single, using whatever currency of account you want to work at. And that way you could come up with a net asset value for the entire portfolio. But the way I've done it here is I've kind of left it I've split it by currency. Now, the other thing to say is you can also kind of create nice formatting for these tables if I wanted to. I deliberately didn't do that because from the point of view of where I'm going, I wanted these to be numeric, so you can do things like sort them and stuff. If you convert them into strings, they don't do that. And while you can, in the data table JavaScript, get it to format it nicely with 2 decimal points and commas and put in some currency symbols and stuff, again, it's kind of messing around and you're kind of fiddling with JavaScript, and it was kind of getting away from what I wanted to talk about in this talk. So I didn't do that. And also, to a certain extent, I'm not planning on this version of the thing. I wouldn't be planning on giving to anyone else. This is kind of for me to kind of show how the code will be working. And in real life, I would be doing it this way. And then maybe later on, once I've kind of figured out what it is I'm doing and how this is going to work, that's when I'll go back and either polish it up or start adding prettier graphs or start putting in other bits and pieces that, for the non-technical people for a presentation point of view. But the data table is a nice kind of, it's data table without the dot. So it's a JavaScript package called capital D, capital T. So there's a JavaScript package called data table, which is basically, it's got some nice JavaScript features for doing things in displaying tabular data in HTML. So you can do things like, sort by numbers. I can sort by sector name. I can actually filter out. So if I put in like financials as well, it will just filter out those. So, it's not particularly necessary for this because we don't, and you've got, nice widgets which you can control. You can set different names and it can be nice. The reason why I'm showing you data table is it can be a nice way of actually displaying tabular data if you do decide to go down like the workbook route. I think there's Python libraries that bring in data table for JavaScript data table as well. So you can put them into your Python notebooks. And it's just a nice way of kind of displaying tabular data that's also interactive and lets you do things like filtering. And it actually can get very, very fancy. I've never really bothered because I generally don't, that to me will be overkill. But if you are producing something that might be like, if you decided, oh, I actually like this, and this is something I'm going to have to do, say, every 3 months or every year, or, every month or every week even, and I want it to be a little bit nice in terms of the presentation, you can certainly add those little bits of bells and whistles. And there's a whole load of online websites and reference sites that will kind of help you through kind of making these kind of workbooks much, much prettier. So yeah, we can segment by market cap quintile because we have it in there. So it's just a matter of, instead of doing it by sector, we do it by market cap quintile. So we could do multiple ones if we wanted it by sector and by market cap. Now this bond portfolio wasn't particularly big. I think the one I was working on was about 50 million US, roughly speaking. I can't remember what this one is. I think I'm sure we could do the maths on it, but I think it was worth it's about the same, I think. But I didn't really, like I said, I was randomly selecting position sizes and stuff. So it's a little bit all over the place. But now we actually get down to, and another reason for kind of doing this as well is, now, obviously I've generated all this randomly, so it's not particularly important here. But the reason why I kind of wanted to talk about this was, this is a good way of also kind of a quick validation check. So like if you're dealing with someone and it's the data, now again, it's a bond portfolio here, but this could be applicable to anything, creating these kind of high level summary statistics and just eyeballing it. So when you look at this, you can see, oh, actually we've got quite a bit of market value in energy. So a big chunk of the portfolio is in energy in Canada. And then obviously America is generally bigger than Canada, which we would expect now. It's a little bit harder to see here because I haven't put those commas in, but you could very easily quickly put that up and just do the formatting, because it's a one-liner, as long as you're happy with the strings. It allows you to very quickly check that everything is okay. Like, does something look right or does it not look right? So if, for example, you knew that there was quite the portfolio should actually have some Canadian dollar real estate bonds in it, and we're seeing zero here, well, then that knows somewhere up above you've made a mistake. Either and it could be a couple of different things. It could be that the data hasn't exported properly and you haven't loaded it in, or something's happened on that side of things. It could be that you've got the ticker symbols wrong, or you've done things backwards, so that when you're actually joining the sector, the sector information piece, that joining piece, something's gone wrong there. There's something you've forgotten. For example, a good, just off the top of my head, what could happen there is, like I said, this is both Canadian and US companies, and we're using the ticker symbol as like the main company identifier, but ticker symbols aren't unique over time, even within a country, but they're certainly not unique across countries. So you could have one company that is basically you could have two companies that are totally different that have the same ticker symbol. So that's why we were kind of separating by Canadian dollar. We have currency in there as another joining factor, but if you forget that, then you'll have misjoins, and you'll basically have, it'll join multiple, the same bond will appear multiple times, one for each currency. You'll have two companies in there that aren't right. So you'll get a lot of issues like that. I've just seen a question there about the underlying data. It's not, the data itself isn't, but there is a generate workbook that does the data generation for you. So once you load it up, if you just render the workbook, it'll spit out some dummy portfolios that will save into data, and that means you should be able to run this.
Nick,
okay, thank you.
Just a quick question, if you don't mind.
Yeah.
Is the underlying data on the GitHub site, or?
Well, it isn't, because I'm generating it all synthetically. So that's what I'm saying. There's a generate workbook in the GitHub repo. In fact, let me just show it. It's probably easier. There is a workbook that should be in there. Data workshops. You can all see that screen, right?
I can, yes.
And then if we go into talk, SEI, generate example bond portfolio. If you render that workbook, it will actually generate the portfolio for you. Oh, but some of the other data might not be in there. I may have forgotten to add that. That will get added later. Sorry, yes. I think some of the market cap data and stuff, I may not have added that to the repo. I just forgot. It's meant to be there, but I didn't. But the underlying bond portfolio isn't and won't be there because it's generated by that workbook.
Okay, very good. Thank you.
Okay. All right. So I'm conscious of the time because we're almost at an hour. So we'll just get down to the brass tacks now of actually creating the cash flow data. So I've created like a couple of helper functions for it. So one of the things I wanted to create was, like I said, the way we made a couple of very simple assumptions because we didn't have a strict coupon schedule for each of the bonds. So we just made the simple underlying assumption that we assume, like from talking to the guys who I was working with, they were kind of happy enough with that as an approximation, because he said, even if it's not strictly accurate, it'll only be out by a day or two, and that's fine. So what we made the assumption was that the bond gets issued at the issuer date, whatever the date of issuance is. And then every 6 months after that, there's a coupon payment, which is half whatever the coupon amount is. And then that continues until the final maturity date, at which point the principal of the bond, which we assumed, again, was $1,000 of whatever the nominal currency was, that gets paid at maturity. We weren't like allowing for like insolvencies or mispayments or anything like that. This was, we weren't making any of those assumptions. That wasn't really the purpose of this. You could certainly add that in, but it would add probably a couple of layers of complexity onto that. So all I'm doing here is I'm just taking like a start date and a final date, dividing by 183, which is half of 365, and then adding them on each time. And that essentially it takes start date, end date, and it creates a table of coupon dates. And it just pops them out. And that becomes that was a little helper function that I would use. Calculating the cash flow data is similar. So I'm taking in the initial date, the final date, whatever the position was. So how many bonds do we owe? Assuming $1,000 for each bond. What is the coupon amount? And I'm making the assumption here that the contract size is just $1,000. In all the data, I didn't actually have the contract size in there because everything was $1,000. But I thought, why not for this? It's so simple to add. Let's put it in now, and it means I'm not editing my code later on. If we do end up with weird things where it's $10,000 or $5,000 or something, some weird kind of edge cases that real life has this unfortunate tendency to throw up. I'm calculating the coupon amounts and adding the coupon payment. And then I'm also adding, because that's just the coupon amounts, I also had to add a final row at the end, which is basically the par value of the portfolio, which is just the position times the contract size. So, if we have 200 bonds, that's $200,000. That's what gets repaid at the end. And again, if you wanted to go fancier and, if real life throws up a bunch of wrinkles on that, it's relatively straightforward to modify this code to do that. But again, I just want to get something quick and dirty down when I was doing this. So I kind of left it at that. And that just puts them all together. So we essentially take basically the various entries in the table, in the bond portfolio table, and that it creates a little mini table for each row. So it's like a nest. They're called nested tables in dplyr. So you can essentially have, if you think of it like an Excel table, it's a mini table within that Excel cell. And what we can do then is just expand them all now. It's called unnest. So you'll see I'll probably be doing that at some point. I do the unnest of the cash data. So essentially, this is a thing that takes in the portfolio data. It's just creating, this is a functional code. It's mapping. So essentially, the idea is that I've got a function that takes a set of values. And what I'm instead doing is I'm vectorizing it. So rather than working for an initial set of values, I can essentially take columns of values and apply this function one by one by one. So I end up with a series of nested tables that's in that row cash data. And then I just expand it all out. Now, the other thing that I didn't do was I didn't, in that previous one here, that was just doing everything from the initial date. It didn't really pay any attention to what the current date was. But obviously, there's no point in looking at cash flow before the time that we're looking at the portfolio. So that's why I have current date in there as a variable, so that any cash flow events that occurred before the particular date in question, we just filter them out. So we're only going to look at future cash flows, and that's what that filter does. So it just says cash flow date is greater than or equal to the current date. So therefore we're going to ignore it. And then we just put it together. So essentially, calculate the bond cash flow. So once we've done with it, we have, we now have a bond portfolio. I have a single function that does all of this. And it, here's the issuer, the ticker symbol and the currency. And then we have this cash flow date and the cash flow amount. So we now have a big long table. You can see there's about 2,000 rows in it. And that shows us all our cash flows. So now you'll see this enters multiple times when you actually look at the data. The data itself, like each bond will have multiple entries depending on how many cash flow events there are. They'll have, in general, there will be at least one, which is the maturity payment. The other thing I didn't do, for those of you who kind of do any of this, even a lot of these were kind of callable and convertible and all that. We ignored all of that. This was purely, we were ignoring any of that kind of stuff. So there is no kind of, price evolution or, dictating early maturity events or anything like that. We were assuming that all these bonds were just being held to maturity, and we were kind of taking the cash flow in from that. So we didn't put any of that in either, because again, that was just kind of making things more complicated. I'm just doing a left join on the company lookup, and I'm showing, again, this is like I said earlier here, I've done the bond cash flow. I'm joining on that company lookup data because we had it for the portfolio data, but we've kind of lost some of that information. So now I'm just appending all that information back on so we can have it. There's a couple of different ways you could have done that. You could have just included those in the output here, but it just seemed easier to me to just do a separate join. And then I'm just checking, like I said, I'm filtering this RNA, is it an empty thing? Because I'm joining on the sector information, I just want to see, are there any cash flow entries in the cash flow table that don't have an associated bond, because a sector, because they all should have. That join should have been proper. And if there aren't, and that sometimes does happen where you get these blanks because in your own head it all makes perfect sense, but when you actually come down to code it, something else occurs. You don't. So it doesn't occur that way. So that happens. And now I've got my full data, which is basically all the portfolio data. And now we can kind of use this to start doing other stuff. So aggregating on a cash flow basis, I'll skip through the code because I'm conscious of the time, but I'm not really doing anything. I'm basically just taking a date and I'm trying to figure out this is kind of some per code. If any you're interested in this, you can explain later. But all I'm really doing is I'm taking the date, I'm taking the list of all the delivery dates for the various futures that we're looking at, or Fridays. Sometimes you get weeklies as well. I figured it'd be handy to do it by every Friday. And you're just taking what's the most recent one that's after the current date. And that's what we're going to aggregate on. So we're essentially all the cash flows up to a certain point in time. And we're kind of going to break all our data into that, kind of like what we did with the quintiles for the market cap, a similar kind of idea. We're just kind of saying, okay, all the cash flows are just going to be aggregated up to this date. And that way we can look at what our accumulated risk position is in the currency at that particular point in time. And that's all that does there. So you can see you end up kind of by dates, creating like an aggregated cash flow. And they're all the same date. I'm not sure why that is. I'm summing up there. Just looking at that now. Oh, sorry, because it's two currencies. Yes, so you see, and I probably should have put a data table in there. In fact, I might clean up this a bit. Now that I've actually gone through it, I'll probably add a few more table outputs. Just it's easier to I realize I'm so used to looking at Glimpse, but for other people, it's probably nicer to put out a little table so you can see all that there. Now we can do the monthly cash flows. I thought, let's just plot them all in. Again, this is kind of a simple, I'm not doing anything fancy here. I'm not doing the aggregation. I'm just taking out the months that the cash flow. So every cash flow event has an actual date associated with it. I'm just taking the month and the year, and then I'm aggregating by month and year. And again, this was purely just a sanity check for the data. Does this look right? Or should, is it spread? Okay, it goes out to about 2024, which is right, because when we generated the data, most of the expirations were about 5 years out at the maximum, and there was like kind of a chunk in the middle. So those all kind of mesh up. That's roughly what we'd expect to see from the portfolio. If we saw something else, again, it's kind of a visual check for us to ensure that it's not really what we want to do. We've this doesn't look right. We've made a mistake somehow, or sometimes it happens that what your intuition is wrong. Like you think something is there, but when you actually view the data and do all of this, you haven't actually made a mistake. Either it isn't what I thought it was, and that's actually correct, or like I said, there's been some weird export issue that hasn't been captured that you haven't kind of figured out yet, and your actual input is wrong. But in some cases, I have had cases where we've done these visual checks. It's thrown up some anomalies, which we thought were a bug in the code, and then we found out, or a bug in the input data, and we've actually found that both the data is correct and the code is correct, and it just wasn't what we thought it was. That does happen from time. It's rare. Almost always when you see an anomaly, it means you've made a mistake or there is an issue. But sometimes, you eliminate all the other possibilities and find, like the Sherlock Holmes thing of, what remains must be the truth. So you kind of, that does happen sometimes. I won't bother with that. So these are all just the futures. So I was kind of bunging them in there and as a quick check to see where they are. But I decided to plot them. So again, this is a visual check to make sure what I'm doing. So I've got the various delivery dates. So because we were looking at futures, the way kind of the delivery dates for futures, like today, there's a couple of like this month, next month, and 3 months out. But then after that, it's every 3 months. So that's why you can see there's kind of short gaps between them. So all I've done there is I have a red vertical line when there's a delivery date, and I'm just doing the aggregated currency exposure by Canadian dollar and US dollar. And I'm just checking to make sure, have I done it properly? Like, has that code I've written earlier? And basically we can see that what happens is once there's a red line where there's a delivery, we can see the accumulated amount is dropping back down to zero. So that kind of looks right. for want of a better term, or at least doesn't necessarily drop down to zero, but close to zero, because it's just the next cash flow event, which might be, a day or two later. So we're not, when I didn't have that initially, and because initially when I created this data, I didn't have the delivery dates in there, it kind of went off once you kind of went through the last delivery, it was just accumulating and accumulating and accumulating. And as a result, the scales were off. But that was a good visual check to show that the check itself was working, because basically we weren't accumulating data past a certain point. Yeah, so, and this is just, I didn't particularly like this. I thought this was kind of ugly. So I just decided to take some points at the maximum value of the delivery date, just as a different one. That it's a stylistic difference. I don't know if it really makes a difference. I think I just preferred that rather than all the red lines, because they just made it, to me, that made it a bit harder to read. I threw in a bit of other stuff here just to show you what you can do now with the data. Like, so I have the Macaulay duration. I have some yield to maturity calculations in there. But again, we can kind of segment it by the various categoricals we have. If you had more, it would be relatively straightforward to do. So I have the yield to maturity in there, and I have a, calculating the NP, the net present value, and then whatever the near zero net present value is. So the optimize basically is just like solver in Excel that does all that. And, just doing them splits. And then I'm just, again, looking at, I calculated the yield to maturity, the implied yield to maturity from my generated bond portfolio based on the different segments, just to get an idea of the spread. Weirdly enough, not all those numbers are crazy, even though I randomly generated them, because even though, we're living in a low interest rate environment, we were actually seeing, certainly a few years ago, and I think it's actually gotten better now in terms of higher yields. The yield to maturity on most of the portfolio was, I think, but the overall portfolio had a yield to maturity of something like 10 or 11 or 12%. In fact, this is probably lower than what we were observing, because I randomly generate the data. But the idea is, this is, again, just a quick visual inspection of all the data to make sure I haven't really made any mistakes. And I think that is, and then some tables out there calculating, the various yield to maturity. We can calculate yield to maturities on different subsets, if that's relevant from a risk point of view. So I've put them in there. And then the other thing I always add at the end of a workbook is a session environment. So basically, this is what this workbook was rendered on. And it just does a simple, there's a nice package session info. I think it's part of the tidyverse. It's certainly available on CRAN. And it just gives a dump of like what the build was on, what the time zone, the packages and the package versions, when they were built, what source it was. Some of them have been built locally. Like I said, that GICS one has come from CRAN, and done all that. So that's kind of all I did. Like I said, it was a quick whistle-stop tour, kind of showing what I've got. The one thing I did actually get asked for is just to show kind of the stuff that's not rendered by the workbook, although you can you'll be able to see this yourselves. But what I'm just going to kind of quickly show that. Like I said, if you like take a normal R Markdown workbook and render it, you don't get this kind of nice layout. This is a layout I discovered about a year and a half ago, maybe 2 years ago, called, it's part of a package called RMD formats, and it's called Read the Down, because there is a kind of a HTML style layout for documentation called Read the Docs. And this kind of uses that overall presentation layer, and it's got some colors and stuff. But you can go kind of crazy with your JavaScript and your CSS if you need to kind of edit all of this. But I do find, like, if I'm generating some kind of nice automated report, for example, this is a very nice way to do it, because you can just kind of create the report, point it at the data. You can even put parameters in here, and you can basically render the workbook with a parameter value. So for example, the input file of the bond portfolio, everything else will stay the same, and it'll just read it from that particular file. And then that will render the portfolio with that particular parameter value. So it can be very handy, for example, if you want to create automated HTML reports. So, you cut down a lot of the crap that you don't necessarily want to do in here. But, if what you're doing isn't necessarily creating HTML files, you would probably not go the R Markdown route. I would still start this way to get it done, because, I can put all my visuals in there, and I can make it I can put some text in there as well. So it kind of becomes self-documenting for me when I come back to it to work on it later. but it does mean that, you know, it can be a bit messy. If you just want something that like takes a CSV file and produces another CSV file or loads something into a database, just creating it as an R script or a Python script is probably the way to go. But again, you know, that's typically the way I would do it. But I end up, because a lot of my work tends to be more on the, I don't really know what I'm doing, I've got to kind of figure it out, rather than more dev work. I find workbooks are really good for that kind of work. I have a whole load of packages in there. This GICS, like I said, is available on GitHub, and it just contains all the kind of the full GICS standard. So it's just a lookup table. It doesn't give you the companies, because that's owned by what's his face, by Standard and Poor's. But it does tell you what all the various codes mean and stuff like that. I've got, I won't bother going into that. If anyone's interested in resolve conflicts, I can happily talk about that. But these are kind of my chunk options. So like warning and message, it means basically when I'm rendering the code, if there's warnings and messages being produced by the code that I'm running, like kind of alerts and stuff, it goes to the console. It doesn't get captured by the output, so therefore it doesn't appear in the final workbook. I love a package called Cowplot, which creates these kind of nice minimal kind of white on these kind of, it's got this style. That's just the theming I use for my plots. I typically use that because I like that. It's nice and clean and relatively, you know, there isn't a lot of extra color in it. I like that kind of, but again, some people like fancier stuff. And there's a whole bunch of theming online as well, where like, you know, the Economist and the New York Times styles and all them. So you can literally just add, you know, you create your ggplot and then you add theme Economist or whatever, and it makes it look like an Economist plot, which is kind of cool. And I know some people have actually, some of the work I've done, they've asked me to use that theme because it looks good and it would impress kind of the powers that be that we're being reported to. Yeah, and then everything else is kind of in there. But yeah, if you do use R Markdown in terms of the stuff, I do recommend looking at RMD formats. I find that quite useful. The code folding hide, that's really nice there. It's this stuff here where I can basically hide my code so that my code is there, but it's kind of hidden behind a fold, so that when I'm looking at my code, all I see is the output. And I think I like that output. But again, your mileage may vary, and it's just you can basically take it out, re-render it, and it'll be completely gone. So that's kind of everything I have to talk about. I realized I've kind of talked pretty constantly now for over an hour. Pedro, do you have any questions for me?
I do, but
Okay.
first of all, thank you very much for all this. I think it is very, very useful.
No problem.
Probably most value will come when people start tinkering with the data at home and
the code. And sorry, thank you. From just before we get into the questions, I should say, like, all of this is GitHub. It's publicly available. You can reach me that way. So if you do have any questions or anything like that, I mean, I don't know if my email has been shared, but by all means, I'm happy to. If you want to try and use this for your own work, it might not even be bond cash flows. It could be something completely separate. Please just drop me a mail. I'm happy to help. We do it all the time, or show up at any of our Dublin data science workshops. Pedro very modestly has mentioned that he's also one of our co-organizers. So like, we do cover insurance stuff and some actuarial stuff. Just by nature of a bunch of us were involved in insurance. So we're kind of done some of these kinds of problems. But yeah, by all means, I'm happy to help. So and thank you for pointing that out about the data. When I get back, I will add those files. I think I just put a git ignore in and didn't add anything because I was very paranoid about accidentally adding in the positions from the company that I worked for, because I had it in originally when I started this work. I didn't have it in the repo, but I had it in the directory. So I was very paranoid about accidentally adding it to Git. So I think I just probably went a bit too far on the risk management. So that will get fixed as of like an hour after this call.
That's a very good, thank you, Mick. I think because I was going through the code and I could see there was a lot of very interesting code there for depending on where people are, different stages of learning. But there's functional programming, there's ggplot, and all the things. So I think there's quite a lot for people to go in there and learn. So one question that we have is, do you have any recommendations for getting stakeholders or managers to accept our output rather than Excel or PowerPoint outputs?
Yeah, if you make it look pretty, to be honest, like, presentation is really important. So I have found some people like Excel. It depends on what they're using it for. If they're using Actuards, sometimes there's not a lot you can do about that. There are libraries that will allow you to create an Excel spreadsheet as output. So you can take like a table and it will create an Excel file rather than a CSV. I have found as long as I can create stuff that's kind of interactive, and you don't necessarily have to use Shiny for that. So Shiny is another kind of suite of packages in R that allows you to very rapidly prototype little websites. And that you can kind of make that interactive, and you can have a front end and a back end, and you can do kind of, you have a server and a UI part, and you can actually, you know, like do computations on the fly and all that kind of stuff. Generally what we would do is we would build quick Shiny dashboards. But I do know someone who did this. Now, it wasn't in insurance. It was kind of in, I think it was, I think it was in utilities. He didn't even bother going the Shiny route, but there are a bunch of packages that allow you to create like interactive JavaScript widgets, kind of like what the data table thing does, but more so. So you can actually create interactive things on it where you get the sliders and the drop downs and stuff, and they change what's being plotted because it's all kind of stored in the single HTML file. And they found that was really, really good. And that they would literally just send someone the HTML file or make the HTML file available on like the internal intranet. And that basically worked in terms of getting their stakeholders. But the key thing I would focus on is making it like nice and useful and pretty. I mean, there is no substitute for something just being attractive to look at, which I will completely hold my hand up at that, you know, I'm not very good at. Actually, though, having said that, that could be a useful thing for like the theming. So if you've got like the New York Times themes or I can't remember, there's a package called, I think it's called GG themes, which allows you to, like I said, put the different plot styles. So your plots looked like a plot that you'd see in The Economist. They've got like the color schemes and the fonts and the font sizes and all the relative. So it kind of looks like one of them. That can be actually a very cheap way of actually getting buy-in, because just it's pleasing to the eye and people are kind of familiar with it. I think there's an FT theme as well. So if you kind of know, for example, if the FT is always on and the senior management always read the FT or something like that, using the FT theme could be like, I know it sounds very cheap and kind of manipulative, but even simple things like that can go a long way to getting buy-in. But ultimately, you might just have to, you know, create an Excel spreadsheet. But you know, it depends. But if I can at all, that has gone down my road. What I will typically do is create a Shiny app and give them a Shiny app, because that way they can because typically a lot of people who use Excel, they're not really doing very much with it anyway. They're just kind of changing a few things and they're not really doing any work in Excel because they're not necessarily technical. So if you give them a website, in many ways, it's actually easier for them than using it in Excel. But, you know, that is very much your mileage may vary.
Very good, thank you. And I have a question of my own. The first time you did this was a few or many years ago. Now you've done it again for the purpose of this talk. What has changed? Like, what lesson have you learned that this version is better because I now know about this?
Yeah, so the original code was written in data table, so which I mentioned earlier was high performance. I kind of started R before the tidyverse existed as a thing. ggplot had kind of just came out, which was kind of the first real package that had started to be used, kind of that was written by a guy called Hadley Wickham, who is now kind of head of the tidyverse. And there is a company kind of behind it, RStudio, which kind of does a lot of the infrastructure behind all of this. So data table was kind of much better than base R. Like base R is pretty terrible, to be quite honest. I mean, some people like it, I don't. I find it very hard to read, and it's just not particularly. I mean, it was amazing for its day, but the world has moved on. So I did a lot of stuff in data table. Data table is a very good example of future you ended up hating current you, because I use data table extensively, but it does look a bit like hieroglyphics because it had a lot of dots and keywords. And now it may have moved on in the last couple of years, and I don't want to knock it because I know some people absolutely love data table and it is incredibly performant. So if you have a large amounts of data that you need to run like in memory and stuff, it has a lot of optimizations that work really, really well for that. But for people who are just getting started, if you're just kind of dipping your toe in, I always recommend the tidyverse for stuff, and then worry about performance later if you actually need it. So I think the fact that the original stuff was all written in data table and this is written in the tidyverse is definitely improvement from the point of view of readability and going back to it. Now, part of it could also be that I'm just a lot more familiar with the tidyverse now. So therefore, of course, it's easier for me to read tidyverse code than it is for me to read data table. But yeah, I did. That's definitely improved. I mean, from my point of view, I use functional code a lot more now. So like I said, functional programming is kind of like where you have functions that operate on functions. So map is a very good example. It takes a function that takes one value and produces another value, and instead it takes a list of values that produces a list of values. So a very good example of it is, let's say it's a square root function. So if you have a function that just takes one value and then calculates the square root of it, you could do map on square root, and then it would take a list of numbers and produce the list of square roots. So that allows me to kind of clean up my code a lot more, but it does take a little bit of getting your head around it. So that's why I've done a little bit of it in there, because you can do the things like the nesting and then the unnesting, and it just becomes a very nice way of handling iteration. So for example, that like running the same code on a table of values, I only have to create a function that focuses on one line and takes all the single inputs. I don't have to worry about writing vectorized code. And then I can just map that function across all the rows of the table. So that makes my code much, much cleaner. It has a slightly more upfront cost, but functional code is getting a lot more common now anyway. So an awful lot of coding, it's much more common now even than like 10 years ago, or even 5 years ago, I would say. It was still a bit of a black art even, I would say 5 years ago, but people have started to realize how powerful it can be. So it's become much more mainstream. So there's a lot more resources out there. But I mean, it's not particularly hard to do some very, very simple stuff. So that would be kind of the other big one would be like R Markdown and being able to build all of this stuff and kind of the infrastructure you can put around it. Like I didn't really want to get into all of this is in a Docker container now. So the whole thing is completely self-contained, so that when I come back, if I want to come back and run this in 5 years time, the code will still run because everything is snapshotted to the date that the Docker container was built. And I don't have to worry about, cran updating all the packages and the code breaking, which is what used to happen to me all the time, which is why I ended up using Docker. So there has been a bunch of changes that certainly R and Python have evolved a lot, even in the 5 years or 6 or 7 years since I first got into insurance, let's say, even though I'd been using them both before that. But yeah, it's definitely becoming easier. And we've got a lot more computational power now at our fingertips. So it's much easier to handle, much larger data sets now that before this would have been unthinkable to use. You can just kind of do them now as kind of a standard cheap €600 laptop that you buy in Currys or something like that. It's actually relatively straightforward to do a lot of that work now because you can just do it all in memory.
Thank you very much, Mick. You've mentioned one thing about using Docker containers. And I think from a risk management point of view, reproducibility and so on, I think that's actually a very interesting topic, but I'm conscious that would probably lead us to an entirely talk
that's a whole separate talk. That's a whole separate talk.
So I'm going to warn you now that maybe that's something in the near future. But
and just to say on that, the one thing I will say about that is it's worth considering, because the standard use case for that kind of stuff doesn't necessarily fit the data manipulation and data analysis directly. It took me a little while to figure out how to use those tools. So yes, there's definitely a conversation to be had there. Not particularly difficult, but the standard use case that you think about that when devs talk about Docker don't necessarily fit the kind of use cases I would have.
Good, thank you. We don't have any more questions, so I'm conscious of time. What I'm going to do is I'm going to thank you, everyone who joined today. I think we've had great attendance, which I like to think that means that there was interest in this, and hopefully we've lived up to the expectations. And thank you, Mick, once again for
no problem, anytime,
for being here today and giving us a very, very interesting talk. So I think with that we can call the meeting to an end now. So thank you.
Sure. Thank you very much.
Thank you. Cheers. Bye.